Hello everyone. Welcome back to the video lecture series on geotechnical engineering with me, Nihal Naveen. In the previous video, we studied the basic concepts of compaction of soil and we also solved a numerical regarding it. In this video, we will be studying about the effects of compaction on the basic soil properties. Okay, and we will also be covering the rest part of compaction. So let's begin the soil compaction part 2. Now coming to the first topic, the factors which are affecting the compaction. The first factor is the water content. As we already have studied about the compaction curve in the previous video, the compaction curve shows the relationship between gamma dry, that is gamma dry unit weight, and water content. Okay, now the graph was like this, and here we used to obtain the MDD, that is maximum dry density, and this one was OMC, that is optimum moisture content. Now why we obtained this graph, I have already told the reason in the previous slide, that as we increase the water content, a layer of water is formed surrounding the soil. Okay, this gives a lubrication effect which makes the soil workable. Okay, and the soil particles start compressing, leading to a denser state of packing. And this finally results in higher dry unit weight. But on further increasing the water content, the volume also starts increasing, which results in decrease in dry unit weight. Okay. Now coming to the second factor, that is the degree of compaction. With the increase in degree of compaction, maximum dry unit weight increases. Let's see, if we increase the degree of compaction, that is the graph comes like this, we find that the maximum dry unit weight, that is this value, it increases. We can see in this graph, and the corresponding OMC decreases. Okay. This is the IS heavy test and this is the IS light test. I have discussed about the properties of IS heavy and light in the previous video. You can recommend it, consult it for further info. And the third factor is the method of compaction. That is for how much time we are applying the compactive effort, the compactive instrument which is being used for compaction, and the area of contact between the surface of the soil as well as the compactive instrument which is being used. All these play an important role in compaction, the compacting element, time, and area of contact. Now let's see how compaction can be done using in the field. Okay. It can be done, the first method is by using rollers. Rollers, as you have seen, the road roller, most common. It is a smooth wheeled roller. Okay, you can see in the video, the roller is smooth wheeled, and this is generally used in road construction activities. And this is suitable for coarse grained soil like gravel and crushed stones. Okay, and here the compaction is achieved by applying pressure over the soil. So pressure is applied over here. Used for crushed stones and gravel, as I have mentioned, and used in road construction. You have to just remember the basic terms which are used and just keep them in mind, because rollers are very important from objective point of view, as it is asked in most of the exams. Okay, so an example for this is tandem roller. Now coming to the second type of roller, that is the sheep's foot roller. You can see the video, you can see the pic here. These are small openings here in the wheel present that provides a kneading action. What is kneading? When you knead the dough to prepare chapati, that process is kneading. Okay, so it gives a mixing effect to the soil, and it is used for cohesive soil, that is silt or sand, silt or clay, and it is used in earthen dams construction. You have to just remember that it is used for cohesive soil. Pneumatic type of roller, here both the action of pressure and kneading is used. Okay, it is a mixture of both this sheep foot roller as well as the smooth wheel roller. It is suitable for all types of soil, but generally it is used for cohesive soil, that is clay. It is used in roadways and for making air strips, air fields. The second type, all these were the types of rollers. Okay, the second type of compacting instrument that is generally used is rammers. It is a small instrument, you can see in this video. This is the rammer. It is used by the basic processes by process of impact. Okay, impact is produced and which leads to compaction. This is used in confined areas where these are not accessible, these large vehicles are not accessible, and it is generally used for cohesionless soil. Okay, cohesionless soil, that is gravel, sand. Now the third item is vibrator. Here vibration is used and it is used for cohesionless soil again, and is the best method for sand compaction. Okay, just remember this, it is the best method for sand compaction, because once this question was asked in GATE. Now, as we are studying the factors which affect compaction, the types of soil also play an important role in compaction. The well-graded soil, that is having particle size of almost all the sizes present, that is a well-graded sand or gravel that has the highest dry density and has the minimum OMC. Okay, now and then sandy clay, then clay with low plasticity, and then clay with high plasticity, and finally uniform sand, that is uniform sand or gravel or uniform coarse aggregate, because they have same diameter of particle. We have to also note here that with increase in organic content, we find that dry density decreases. Okay, and corresponding OMC increases, that is the graph shifts here in the downward direction like this. Okay, when we increase the organic content, it makes the soil weak. Now this is an important concept, many theoretical concepts are asked from this. The effects of compaction on soil properties. Okay, first is the effect on soil structure. At lower water content, attractive forces are stronger. We have already studied about the flocculated structure and the dispersed structure in the previous slide. The flocculated structure is formed by edge to edge and edge to surface like this, and they have huge voids in between. Okay, this is the flocculated structure. Here the compressibility is less, as I have already mentioned in the previous slides. This is the flocculated. Okay, and in dispersed, the voids reduce. This is the dispersed case. Okay, so when we have lower water content, attractive forces are stronger and it is a flocculated state. And in higher water content, the repulsive forces are greater, and so it is a dispersed structure. Now we see this graph, that is a compaction graph. This is the line of optimum. Okay, in this part we have dry side of optimum, and here we have wet side of optimum. Okay, this we already know is the dry unit weight, and here on the x-axis we have water content. Now we find that as the water content increases, that means we are moving on the wet side of optimum, we find that the structure changes into dispersed. Okay, that is orientation is improved. What does orientation means? Orientation means actually the void is decreasing, that is orientation. And when you are moving to the dry side of optimum, we find that the structure becomes flocculated in nature. With increase in water content at same compactive effort, orientation of particles improve. Okay, and at same water content, increase in compactive effort improves orientation. Let's see this. Let this be a heavy compaction test where more energy is applied and water content is same in both these cases. Okay, let this point be A, this be B, this is C and this is D. Okay. It is given with increase in water content at same compactive effort. That is, when we are applying the same compactive effort, we find that orientation of particles improve. That is, towards the C, orientation is improving. That is, the void is decreasing. So C has greater orientation than D. And at same water percentage, that is, in this case, same water content, increase in compactive effort improves orientation. Okay. That means A has better orientation than D. But here we can't find which has better orientation in case of A and C, because as we go to the wet side of optimum, we see the orientation improve, and as we go upwards, that means we increase the compactive effort, that at that time also the orientation improve. So here is a controversy. So we can't find the values between A and C. So they are not comparable actually. Now moving on to the next effect, that is the effect on permeability, effect of compaction on permeability, that is K. Now as we all know that permeability depends on the size of void, and that's why the permeability of sand is greater than clay. Though clay has greater number of voids, but the size of void is less, so permeability of sand is more. With increased water percentage, the orientation improves, as I have already told, and voids decrease. So they are less permeable, as in case of dispersed structure. And with increased compactive effort, the void's size reduce. Okay. When we increase the compactive effort, naturally, when we are applying the load, the void size will decrease, and this will give less permeability. So this is how compaction affects permeability. Now moving on to the next, that is compressibility. Dispersed structures, that is on the wet side of optimum, they are more compressible than the flocculated structure. Okay. And so compressibility increases on the wet side. That is, liquid limit also increases, so compressibility increases. Now coming to how compaction affects the strength of the soil. On the dry side, we have more strength compared to the wet side. Okay. The next is shrinkage. In wet side, shrinkage is more. Why? Because of nearly parallel orientation of particles. And unless the soil is wet, there can't be any shrinkage. So it will shrink more on drying. When moving on from the wet side to the line of optimum. Okay. You have to remember this, what happens when in case of shrinkage and swelling, because generally we confuse in this too. In swelling, because dry side has more swelling properties, it has random arrangement. Why? Flocculated structure has random arrangement and more number of voids. So naturally it can swell more when less water is applied. So dry side of optimum has more swelling properties. And in failure, the failure we have dry side, we have brittle failure, and wet side we have ductile failure. Okay. Just you have to remember this, how it affects the soil properties. Now coming to the next topic, that is compaction of sand. Compaction of sand is completely different from compaction of clay, and its relation is not defined between water content and dry density as we found in compaction curve. Here we have a varying graph, okay, and it is not well defined in case of pure sand. Let's see this graph. We find that first the dry density was this, and then it decreased. On applying a small quantity of water, that is around 5 to 6%, we find that the water particle, they surround the particles of the sand, and which finally leads to apparent cohesion, leading to increase in volume. Okay. And this increase in volume leads to bulking of sand. That is the concept of bulking of sand. When small water content is applied, that is 5 to 6%, there is huge change in volume of sand, that is bulking of sand. And when volume increases, naturally the dry density will decrease. So there comes a point, that is B, that is point of lowest density, when the volume is at the maximum level, that is around 5 to 6% of water content. And now again, when we are increasing the water content, we find that the volume starts decreasing as apparent cohesion starts decreasing. Okay. So when we have to find the gamma D maximum, this value is obtained when sand gets completely saturated, that is at 100% saturation. Okay, here the volume is minimum. What I have explained is written in these 2 points. Let's read this. When water content is increased up to 5 to 6%, there is increase in apparent cohesion, okay, which increases the volume of sand, and this property is known as bulking of sand. These are generally asked in the interviews, what is bulking of sand? As water content is increased beyond 5 to 6%, apparent cohesion decreases, okay, it decreases, which decreases volume of sand, thus increasing the dry density. So that's how we have obtained this varying graph. So let's see some of the few theoretical questions which were asked in GATE. This was asked in year 2006 for 1 mark. Compaction by vibratory roller is the best method of compaction in the case of A. Moist silty clay, B. Well graded dry sand, C. Clay of medium compressibility, and D. Silt of high compressibility. Now unless we remember this, I have already taught about the vibratory roller and I have also given the images so that you can keep in mind. Now coming to the vibratory roller, it is the best method for sand compaction. I have already told you before, it is best method and it is used for cohesionless soil. So coming to the question again, this vibratory roller is same as vibrators, okay, and it is used for well graded dry sand. So option B. They may also ask which roller is best used for clay or cohesive soil. You will write sheep foot roller, okay, and which is used for generally gravel or sand, that is the first one, that was smooth wheel roller, okay. You have to remember the names. So moving on to the next question, this was asked in year 2016. OMC SP and MDD SP. OMC is optimum moisture content and MDD is maximum dry density. Denote the optimum moisture content and maximum dry density obtained from standard Proctor test, okay, respectively. And OMC MP and MDD MP denote the optimum moisture content and maximum dry density obtained from modified Proctor test. MP denotes modified Proctor. Which of the following is correct? Okay, here 4 options are given. We have to find the correct option. Now we have already studied about the graph. This was the graph for standard Proctor test and this was the graph for modified Proctor test. Okay, this was the MD value, MDD, MP, okay, and this is the value for MDD, SP, and this is the value for OMC, SP, and this is the value for OMC, MP, okay. Now through this graph we can easily find this answer. The OMC, SP, that is standard Proctor test, is greater than OMC, MP, okay. This value is greater than this value, so this is correct. And MDD of modified Proctor test, that is maximum dry density of modified Proctor test, is greater than of standard Proctor test. So this. So option B is correct. Okay. So we have come to the end of this video. Hope you find this video informative. In the upcoming videos, we will be studying the concepts of effective stress and pore water pressure in great detail, which will be very important from the GATE point of view. You can also practice free quizzes at Grade Up and always be a grade higher. All the best. Thank you.